Okay, so guys, in this video we are going to discuss something which is very basic. Okay, a lot of people know about it, but yeah, it is actually linked to something relating to the derivatives and some second derivative test. I am pretty sure that you have heard about it, but yeah, this topic is actually linked to the second derivative test, so I'm going to revise this topic first of all, and then in the upcoming videos we will be discussing the second derivative test and all that. The question says determine the intervals for which the function is increasing or decreasing for the given domain. Now, when you have to find the increasing points and the decreasing points, there are some things which you should consider, and those things are the x value. You should only focus on the x values. Those x values are your domain, and by focusing on those x values and plotting the graph according to the given conditions, you will get the value of y, and that y is going to be your range. Okay, for drawing any sort of graph, the only thing which is important is the x value. Now, from now onwards, wherever you are told to find the relative minima, maxima, I'm going to explain what these terms are, don't worry about it. But if anyone asks you to find the relative minima, the maxima, the relative extremas, or anything like that, you should always focus on the x value given to you. Okay, if the graph is going up, it is of course increasing. If the graph is going down, it is decreasing. So this point is actually increasing point, and this point is known as the decreasing point, and this is the point where the graph is constant. It is constant for a while. The graph has stopped, or the graph can also be looking like this point. Okay, so both of these points are the points at which the graph has stopped. The graph is constant. These points have some specific names. If the graph is increasing and this point, the point which is constant, is located on the height of the graph, it is known as the maximum point. And if this point is located at a point where the graph is going downwards, at the point where the graph is decreasing, that point is known as the minimum value. And this maxima and this minima combined are known as the relative extrema. So now let's solve one problem over here. First of all, we have the function sine of x, and the question actually says that you have to determine the interval for which the function is increasing or decreasing. So we have to determine what is the maxima and what is the minima for the domain given. Now, what is the domain? The domain given to us will be given in the format of x is a member of negative pi to pi. So you have to basically draw the graph from negative pi to pi. Now, what is negative pi? Negative pi is actually the radian format of 180 degrees. Okay, negative pi actually, it is actually saying that the graph, the value of sine will be taken from the negative 180 to the positive 180. Now I'm calling this point as the negative 180. You know why? Because this point on a graph on a degree is actually 0, and it is totally opposite to the positive 180. If we draw a degree over here, which you have probably seen in the geometry box, this point is known as 180, right? And this point is 0. This is the positive 180. Directly opposite to it is of course what? This is 0, right? And in other words, it can be called as the negative 180. So this is the thing, and the question is actually saying that your domain actually falls between these 2 points. Okay, so what are the significant values? Okay, so between 180 and negative 180, we have values like, if we start from negative 180, we have negative 120, we have negative 90, then we have 0, and then 90, 45. We have all those sorts of values. Now, which values are we going to take? We will take 2 values from the negative side, and we will take 2 values from the positive side, and the 0 will be at the. So let's begin our x. Now this domain is actually the x value. Okay, so the question was actually saying that x is a member of negative pi. So this is the x value, and what I told you, your x is the domain. You have to focus on x. By solving for x, you will get y. So let's see, this is the x value, this is the y value, and the function is actually sine x. So first of all, we have negative pi, then we have pi by 2, negative pi by 2, which is actually 90 degrees. Then we have 0, then we have pi by 2, and then we have pi. So you can see how the function is increasing. First of all, we had negative 180, then we have negative 90, then 0, then 90, then 180. So we've actually written the domain in the ascending format. What is the value of sine at negative pi? What is the value of sine at negative 180 degrees? At 180 degrees, the value of sine is 0. What will be the value at negative 180? Of course, it will be 0. What is the value of sine at 90 degrees? It is 1. For the negative, we will have negative 1. but the value of sine at 0 is 0. The value of sine at pi by 2 is 1, and the value of sine at pi is of course 0. So now we can actually draw our graph. How we can draw the graph? You can actually draw it on Desmos if you like, but we will draw it manually over here. First of all, we will have the x values, we will have the y values. So the points which we have taken into consideration are 0, 90, 180, negative 90, negative 180. The values are increasing. The maximum value of y we have is 1. So we can write 1 over here, and this is the most negative value, the lowest possible value, that is negative 1. And this is the highest possible value, 1. For the function sine, the value of sine at 0 degrees was 0 degrees. So we have 0, 0 over here. Then the value of sine at pi by 2, 90 degrees was 1. So here we have pi by 2, 1. The value of sine at 180 degrees was 0. The value of sine at negative 90 was negative 1. And the value of sine at 180 degrees was 0. So the function is actually increasing in this form. And this point is known as the maximum. At this point, the graph has stopped and is at the maximum point. This point is known as the minimum. At this point, the graph is stopped for a while and is having the lowest possible value. Okay, so we can see now, I told you that the function increases when the slope is actually increasing, and the function decreases when the slope is decreasing. For our situation, so the function, let me just write it down roughly over here. So the function is decreasing at points negative 180, negative pi to negative pi by 2. Then the function increases from 90 degrees to 0 degrees. So the function increases from negative 90 degrees to 0 degrees. Then the function continues to increase from 0 degrees to 90 degrees. So again, we have an increase from 0 degrees to 90 degrees. Then the function decreases from 90 degrees to 180 degrees. Now we have a function 4 minus x squared. So we have to focus on what are the x values, okay? And then ultimately we will get the y values. We can take the value of x as anything. We can take it 1, 2, 3, negative 1, negative 2, negative 3. But I will take the value of x as both negative and the positive. And of course you will have, and at any cost, I will recommend you to include the 0 in your domain. So we have x, we have y, and the function is 4 minus x squared. So we will take value negative 2, negative 1. So now let's see what is the value of 4 minus x squared when we put in the value of x as negative 2. So we have 4 minus 2 whole square. 4 minus 2 whole square is actually 4. So 4 minus 4 would be 0. And then we have the value of x as negative 1. What will be the value of y if we process this value of x through the function? So 4 minus 1 whole square. So we have 4 minus 1 whole square is actually equal to 1, which is 3. So we have 3. At 0, the value of this function will be 4. At 1, the value of this function will be 3. And at 2, the value of this function will again be 0. So now we can actually draw a graph for this function. So we can see that the graph, the maximum value the graph reaches is 4. And the graph does not have any negative values. So we can stop worrying about that. So we have 1, 2, negative 1, negative 2 as our domains. This is the x value, this is the y. This is the first, second, third, and the fourth coordinate of y. When we were having the value of x as negative 2, we had the value of y as 0. So for negative 2, you have the value of 0. This is the point. Then we have, when we were having negative 1 x, then the value of y was 3. So negative 1 is opposed to 3. Then we have 0 and 4. So 0 and 4. This will be, the x is 0, but the y is 4. So this will be over here. X as 1 and y as 3. So this is the point. And then we have x as 2 and y as 0. So this is the point. So remember, whenever you're having the value of y equal to 0, the point will be lying on the x-axis. And if you have the value of x as 0, the point will be lying on the y-axis. Okay, so now let's draw this graph. This graph will be increasing from this point, and then it will continue decreasing from this point. So the graph increases from negative 2 to negative 1, increases from negative 2 to negative 1. Then it continues increasing from negative 1 to 0. So it continues increasing from negative 1 to 0. Remember, I'm considering the x values. Okay, these are all x values. Then the graph decreases from 0 to 1. And then the graph decreases from 1 to 2, and it reaches, this point is known as the minimum. And of course, this point will also be known as the minimum. And this point is the highest point the graph has achieved. So this is the maximum. And the graph has decreased from 1 to 2. So this is the range for our function.